It's wind. So you've got the jet stream that runs across, the country. That in general, you've got a pattern of wind going in one direction all the time. Especially when we're talking about up at high altitudes where a plane is going to fly. So if you are going eastbound, if you are flying to the east, then you have the jet stream pushing you along, right? The jet stream is going to add to your speed. But if you're flying to the west, then you have the jet stream working against you, right? You're flying into the wind, which is going to slow you down. So that's the reason these are not the same. And of course, weather conditions would affect this some, but in general, this would be the pattern that you would see. On average, you would see westbound flights taking longer than eastbound flights in most cases. All right, so let's also find a line for distance versus eastbound flight time. So we're going to have to do something a little bit different here. Okay? Our westbound flight time, it was Y1 in our table here. What is our eastbound flight time? It is Y2. Okay? So if we want to find a line using these purple dots instead of the green dots, we're still going to say, we're still going to use X1 because that doesn't change. But instead of saying Y1, we're going to say Y2. Squiggle M X1 plus B. Okay, yes? The reason that we keep the 1 is because this is still in the same table. So this X1 is still our distance right here. So we still want to use that as our distance. So we're going to leave it the same. But the Y2 is our eastbound flight, so we need to use it instead of this middle column. So when we did our first line, we didn't use Y2 at all, so it was like we were just using those first two. This time, we're not using that middle column at all. We're using the X column and the last column. Okay, does that make sense? All right. So, questions? And you can see whenever I type that in, the line that this graphs, let me change its color actually. Let's make it, I'll make it purple to match the points. So, you can see that it goes through our purple points here. Okay, let's write our equation for that one. So, y equals 0.103 x plus 47.022. Unless I tell you otherwise, round it to 3 decimal places for me. Okay, questions on anything so far? All right, now 3 tells us the flight distance from Chicago to Charlotte is 599 miles. Use one of your lines to estimate the flight time for a plane traveling from Chicago to Charlotte. So I've got 2 different lines here. I'm not going to use both of them. Which one am I going to use if I'm going from Chicago to Charlotte? Yeah. Okay, so this is a geography question in a way, right? All right. So, where's Chicago? It's such a big city, it shows up pretty quick. Chicago's in Illinois. It's right here at the bottom of Lake Michigan. Okay? From Chicago to Charlotte, if you start in Chicago and going to Charlotte, I realize you're going a lot south, but are you going to the east or to the west? East. So which line should we use, number 1 or number 2? 2. All right, so we're going to do y equals 0.103 times 599 plus 47.022. And we can use our calculator for this. In Desmos, when you type something like this in, you just type it in, we'll give you the answer. All right, and I get 108.718. I'm sorry, 719. I don't know, I said 8. All right, and what is this measured in? Is that miles, minutes, hours, days?
Flight time, so minutes.
It is minutes. Okay, so how long is that? How many hours?
It's like an hour and some. It's over an hour and a half, but it's not 2 hours.
Right, so 2 hours would be 120. Right, so it's a little shy of 2 hours.
But an hour and a half would be 90. So it's like an hour and 48 minutes.
Yeah, hour and 48
I
minutes.
thought Chicago was a state, but that could be counted.
Chicago, oh my God.
Okay,
Chicago
so
was a state.
if we're going from Chicago to Charlotte, estimate it to be about 108 minutes.
That's what I thought.
No, it's in Illinois. It's a city.
I also thought New England was in Europe, and I thought Russia was a country. I also thought Washington, D.C. was an actual state of Washington.
Okay, so this time, what about if we start in Charlotte and we go to Chicago? So if we wanted to go to Chicago from here, this is what we'd probably do, right? We'd go to Charlotte, we'd get on a plane, we'd fly to Chicago. All right, and we get 121.664. So this would be a little bit over 2 hours to get from Charlotte to Chicago. Would be a little over 2 hours. Yep, 2 hours and 1 minute, 1.5 minutes. Okay, so we want to know more. We could find other places between, Chicago and other places, and we could use the same data to kind of get an estimate there. It's not perfect, and it certainly does not account for like weather conditions that you might need to consider, but it would give you a good estimate. Okay, questions? All right. Okay, questions? All right. Okay. Okay, so we're going to watch this just because it's cool. Wade, can you get the lights off for me? It's slightly related. All right, so we're not going to watch this first video because it's long and it takes a while to do. So whenever we're talking about, actually, let's just watch this. We're going to watch the second video. This is not the highest, but not the highest. I'll just let you guys watch it here. Hold on just a second. Let me switch to the. No, sorry. The footage for this one's better than the other one because it was sponsored by Red Bull.
This was sponsored by Red Bull.
Skateboard, isn't it?
That looks so I could never do that. I'm sorry. I'm scared of heights.
Then he starts spinning really fast.
Alright, so. Sorry.
It's a robot.
So that was footage of Felix Bumgardner. He jumped in October 2012, and he jumped from 128,000 feet. In 2014, Alan Eustace jumped from 135,000 feet. We're not gonna watch his whole video because it's like 15 minutes long. But he talks about. This is pretty cool if you ever watch this.
Only one happy, but parachute and drove parachute.
Let's see. Does it show him jumping? I should have. Red Bull sponsored the other one. This guy was super rich. He was a. There we go.
Van to go to the launch pad, but I got a front loader.
He did not have like a capsule.
You can see the balloon up there.
He just had a spacesuit.
This is Dave clearing the airspace with the FAA for 15 months.
So he just like.
That's me waving with my left hand. The reason I'm waving with my left hand is because on the right hand is the emergency cutaway. My team forbade me from using my right hand.
He's just
So the
hanging
trip
from
up is
the
beautiful.
balloon.
It's kind of like Google Earth in reverse. It took 2 hours and 7 minutes to go up, and it was the most peaceful 2 hours and 7 minutes. I was mostly trying to relax.
Yeah.
My heart rate was very low,
So that's
and I
what
was
he
trying
did.
not to use very much oxygen.
I couldn't do that.
You can see how the fields in the background are relatively big at this point, and you can see me going up and up. It's interesting here because if you look, I'm right over the airport, and I'm probably 50,000 feet. But immediately I'm about to go into a stratospheric wind of over 120 miles an hour. This is my flight director telling me that I had just gone higher than anybody else had ever gone in a balloon. And I was about 4,000 feet from release. This is what it looks like. You can see the darkness of space, the curvature of the Earth, fragile planet below. I'm practicing my emergency procedures mentally right now. If anything goes wrong, I want to be ready. And the main thing that I want to do here is to have a release and fall and stay completely stable. There's a balloon going by, fully inflated at this point. And there you can see a drogue parachute, which I'll demonstrate in just a second because that's really important. There's the balloon going by a second time.
His jump footage is not nearly as good.
Right now I'm about at the speed of sound.
'Cause it's mostly from
There's
his
nothing
phone.
for me to tell it's the speed of sound. And very soon I'll actually be as fast as I ever get, 822 miles an hour.
Ooh, crowd. I'm scared of float. You should. Shoot, I've never been more scared in my life compared to
So now I'm down low right now, and you can basically see the parachute come out right there. At this point, I'm very happy that there's a parachute out. I thought I was the only one happy, but it turns out Mission Control was really happy as well. The really nice thing about this is the moment I opened, I had a close friend of mine, Blinky's, my parachute guy. He flew in another airplane, and he actually jumped out and landed right next to me. He was my wingman on the descent. This is my landing, but it's probably more properly called a crash. I hate to admit it, but it wasn't even close to my worst landing.
Okay.
Did you do that, Miss Hines?
No.
People have broken their legs.
No, thank you.
So
All right.
what happened if you fell from
So-
that distance and you didn't open your parachute? What would happen to your body?
You would
You
like,
die. You would get crushed. Actually, your bones would crush.
Yeah, you would.
you would dig yourself in the
You
grave.
die? I mean, I knew you'd die.
They wouldn't even have to hire
that's a
a grave
painful-
digger.
that's a
Just
painful
throw
way to
the
die.
dirt in on top of your hole.
It
All right,
depends
so-
how you land on it.
All right.
You bounce. It's crazy.
Okay, so as you can tell from just like the room full of people that it took for these people to jump from those sort of heights, there is a lot involved from doing something like this. There's a lot involved if you want to jump out of a plane. Just go like pay your $500 or whatever it costs to go let somebody jump out of a plane. There's a lot involved there, but as far as the science behind it goes, it's incredible what has to be done to jump from heights like this. I'm not sure about the Felix guy. The Alan Eustace guy was like a high-ranking executive at Google, I think is what he did.
What happens if your
So that's like what he wanted to do in retirement.
Right.
You bounce.
So-
You gotta sit down and you bounce.
So I think he like funded this on his own,
Like, how would you guys bounce? Like, not
So-
bouncing a good way, like your body.
Quiet. So, one thing that is something that has to be considered is temperature. Because whenever you start getting up to those heights, the temperature on this chart right here at 34,000 feet, which is not even close to as high as these guys were, temperature is negative 58 degrees.
That's cold.
So you can't survive in negative 58 degree temperatures. What's the other problem with being at 34,000 feet? Why else can't you just go up there in your short and t-shirts? Oxygen. There's not enough oxygen at that level. That's why when you're in a plane, the cabin's pressurized, and if you lose pressure, you are in trouble. So,
Is that why, like, if something happens in the plane, it's like masks fall down?
So, there's a lot of stuff that has to be considered. So, we just kind of watched this to, like, think about a situation where this is going to be something you need to look at, right? So, this data right here gives us altitude and temperature, okay? So, we're going to enter this into Desmos. So, you have it there on your paper, and I'm going to enter it up here as well. So, just go ahead and do new blank graph. If you hit the three bars right here and tell it new blank graph, that'll be easier. And we're going to hit the plus sign and table, and we are going to enter. This is just one chart, even though it's side by side. They just did that to save room. I took this from a textbook. So 34.6. So look there. Everybody should be typing it in right now. I'm going to come around to check to see that you got it in. So don't sit back and just watch. Everybody typing it in. Oops. It's on your paper, or you can look up here.
That's a lot of numbers.
So we were typing in altitude.
it's just a continued table. So like when you get down here to 9.5, you go to 6.6.
So there's two. So we're just doing this.
It's one table. They just put them side by side to make it fit. So
Okay.
it's when you get here to 9.5, just keep going. It's going to be 6.6, 4.2, 2.1, 0.6, 0.1. And you can just look at what I have here if you would like. All right, so make sure you've got your data in.
So he was off Earth.
Yeah, he was in the
Why would you want to go that
stratosphere.
He was what?
Stratosphere, which is like not space, but it's, yeah.
Mr. Comstock, you talking about?
Okay. All right, so once you have your data in, you're supposed to find your linear model. Quiet, please. So you're going to do y1 squiggle mx1 plus b. Okay, so I'm getting y equals the slope, which is our m, is negative 3.613. And then my b is 63.411. And I'm going to zoom back out a little bit so that... Now, over here on my graph, I can't really see anything. I don't see any points. There, if I move it over here, I see like 1 point, but that's not very helpful, right? Why can't I see a good graph here? Okay? So, if you just zoom out, here's the problem with just zooming out. Sometimes it makes all the data points really like small and close together. So the best thing to do to get a good picture here is you're going to hit the wrench. What is, for our x's, what's our lowest number? 0.1. What's our highest? 34.6. So right here for x-axis, I'm just going to use 0 and 35. Okay? And then for my y, my lowest number is negative 58. My highest number is 65. And then you probably want to zoom in just a little bit from there, or yeah, zoom in just a little bit from there, and it'll give you a nice picture. Okay, so what you're putting in here, okay, it doesn't matter the exact numbers. You don't have to get the exact numbers. What you're doing is you're setting this range so that it covers all of your x values. So the numbers I typed in were 0 to 35 because 0 to 35 covered all of my x's there. And then my y-axis, it was from negative 58 to 65 is what I put in there. They changed a little bit whenever I zoomed out just a little bit. So you're just trying, and yours doesn't have to be exactly like someone else's, but it'll get you a better picture so you can see what's happening Okay, so our question says use your model to estimate the temperature at an altitude of 5,000 feet. Okay, now I can tell on my graph, my table here, it should be somewhere between 39 and 49, but I want a more specific guess. Yes?
So, would you have to do like 5,000 people? Because it's the law? No, this is the X.
All right, so feet is altitude. Was that our X or our Y? It's X. We put it in the X column, right? This 34.6, that is altitude. But it is in thousands of feet. So what number should I use when I'm plugging it in? What? Not 5,000. Why would I not use 5,000? None of these other ones are thousands. Right here it says altitude in thousands of feet. So if I want to plug in 5,000 feet, I just plug in 5. Okay? So my X is 5. So I can do this by hand, and I'm going to show you a cool shortcut on Desmos. So I could do it by hand. And if you do that, I get 45.346. Or, let me show you a really cool shortcut that you can use here. Was 5, was it an X or Y? What did I plug it in for? X. Okay. So I know that what I did there is I said X equals 5. Okay, watch this over here on Desmos. If I type X equals 5, it's going to put me a vertical line right here at X equals 5. Notice that I've got a gray dot right there. If I put my cursor right there, on that point, it will tell me the exact value. It's actually just a little bit different because we rounded right here for this number, but we did not round over here. And so you can see you've got 5, and then you get 45.347. So you could do that straight off and not even have to type everything in. Right? So, round to 3 places. I think Desmos typically does round to 3 places for you. Your rounding will be slightly different than what you have here. This answer, 45.347, is actually more exact than 45.346 because this black line right here, whenever it's graphed, it has not been rounded. Those numbers haven't been rounded. So doing it this way is actually a little bit more precise for this. When we take our quiz on Friday, it is going to be on paper, so I will take that into account. And if you're reasonably close, then it'll be okay. You won't have to be quite so precise on your round. Okay. Use your model to estimate the altitude at which the temperature is 0 degrees Fahrenheit. So 0 degrees Fahrenheit, is that X or Y? Y was our temperature, right? So Y equals 0 is what we're looking at here. So if we think about that same thing here, I'm going to get rid of that line. That's right here. We could do this a couple ways. The quickest and most exact way is just to type in Y equals 0. It's going to put in a horizontal line. Okay? And so if you do that, then if you go over here to where those lines cross, you see that gray dot there, I get 17.552. So it would be 17.552. That's an altitude. So what is that? Feet, miles, years, days? Okay, I like what Owen said. He said 1,000 feet. Or an even better way is just move that decimal 3 places to make this 1,000, 17,552 feet. You got to say one of these. You can't just say 17.552 because it is not 17.552 feet. It's 17,552 feet. To me, this is the easiest and quickest way to do this problem, but let's say that you can't remember what to type into Desmos. You could always do this by hand. Plug in 0 for your y. And then just solve that equation. You got to subtract the 63.411. Divide by negative 3.613. And so whenever we do that, we get, this time we would get 17.551. So you'd be off by 1 foot because of the round in there, but that's going to be okay for our purposes here. Now, there are times where you would not want to round that much because even tiny, tiny amounts could cause a major issue there. Julian, you got this down? Julian, wake up. Yeah, I should. Oh, water gun. All right. Okay. Questions on this one? Easton, why is that phone out?
Not him trying to make an excuse.
Okay. All right. Let's look at this next one. Okay, so the table below gives the cost of tiling a floor given the size of the floor. So the size of the floor in square feet is given, and then the cost is given here. So we want to put this data into Desmos. So start your new graph there. So if you just click the 3 dots, you can say new blank graph. What do I hit? What do I hit to get the
table, the plus,
plus
and the table.
table? Okay. Let's enter our data. No. In general, I am not going to try to trip you up. The X is pretty much always going to be that first line. And the Y is going to be that second line. Or the X is going to be whatever's on the left. Y is going to be whatever's on the right. So in this case, it's your dependent variable and your independent variable. So the independent variable is the size of the floor, right? Because the cost depends on how big the floor is. Hello? Yes. All right, bye. Ayla, Easton, and Jada, you guys need to go to the office. I don't know why. Good luck. Okay. All right, so enter your data. Everybody enter it right now.
And they already did it.
All right, everybody type in your data. technically that doesn't have to be the case, but I'm not going to try to trip you up on that. And usually on like state tests and stuff like that, they don't usually do that either. Usually it's always that top line is your X, the bottom line is your Y. All right. Okay. Okay. All right. Everybody should have their data in. So everybody got it in?
No.
All right. Data, not important. Get your data in. Fast, quiet. Okay. So, we've got our data in. I see nothing. All right. Especially on this one, if you zoom out enough to be able to see it, you're really going to have like a really bunched up together group of points here. So, if we hit the wrench, okay? All right, so for our X, what's our lowest X? 150? So, right here, we're going to type in 150. What's our highest X? 420. Okay? What's our lowest Y? 690. What's our highest Y? 1600. All right, now, you want to, when you graph this, you want to zoom out a little bit after doing that. But that should give you a pretty good picture there. Okay, questions? All right, the first question over here asked me to find a line of best fit for the data. So, Peyton, what do I have to do to find that line of best fit? Y1. Yes. Yeah. Okay. So, Vince, you have a question or? Okay. So, tell me what that equation is going to look like. Yeah. Or, well, it's your slope. It's not your X. It's your slope. It goes beside your X. Good. Very good. Okay. Any questions so far? All right, so let's try using that shortcut to help us answer number 2. It says use your model, and whenever it says use your model, it does not mean use the table. It does not mean guess at this. It means use the equation. The model is the equation. Okay? So use your model to help to predict the cost of tiling 600 square feet. Okay? So 600 I know I need to plug in. Am I going to plug it in as an X or a Y? It is an X because size of floor is X. So X equals 600. Okay? So, let's do it the way that we could plug it in just to the equation, all right? We also could just do this. We could say x equals 600. It's not showing up, but it's not showing up because, look, we don't even go out to 600 right here. So zoom out a little bit more. And if you click on one of these two lines and go to that gray dot, it's going to tell you where they cross. And so what do you get, Vince?
2291.
And actually on this one, let's round to 2 places. Why would we round to 2 places on this? It is cost. So we'll do 3, 4 because this would be money. So in general, rounding money to 2 places is what we want to do. So 6,000 square feet would cost you $2,291.34. Questions? All right, let's finish up these last 2 here. So we worked on this some when we were doing word problems. Okay? It's the same thing. So we are asked about y-intercept and slope. Okay? So who could tell me what the y-intercept is going to mean? Jada?
The y-intercept are like the triangle on the
No, that's slope.
Okay, so when you're on every 16 foot. Yeah, every it's $1,600 every square foot or something.
Where are you getting 1,600?
I don't know.
Okay. What do you think, Wade? What size?
Square feet.
How many square feet?
So
Okay.
would the y-intercept be how much it costs for the company to come out there originally without 1,000?
So, when x equals 0, y equals the y-intercept, right? So y-intercept is 199.391. Okay? X stands for size of floor. And y is cost in dollars. Right? So y-intercept tells us when x equals 0, y equals this. So when the size of the floor is 0, it costs $199 or $199.39, right? So you could say that. You could say to tile a 0 square foot floor, it costs $199.39. Or it doesn't make sense. Like if you're not going to tile anything, you're not going to have somebody even work, right? So this is the base fee right here. So the base fee is $199. I'm going to round that to 39 cents since we're talking about money. Now slope is changing y over changing x. And our slope is 3.487. And we're going to put that over 1. Y stands for cost. And X stands for square feet. Now, a slope gives us a rate of change, a rate that we're looking at here. So what could you tell me about this situation? Owen?
It costs $3.49 per square foot.
So this company is charging $3.94 for every square foot, right? And you can word it some different ways there. That's our general idea. Okay, so if you finish the warm-up, there is no homework. If you did not finish the warm-up this morning, I want you to finish that at home tonight, okay?